just isn't well designed historically speaking to withstand earthquakes, and death tolls often reach tens of thousands from past major events. Early information even notes that a skyscraper Bangkok collapse under construction in Bangkok, Thailand collapsed. I have an unverified opinion on why that tragedy occurred. You can see the point of failure in social media footage being the bottom 3-story high pillars, marking the entire building as a massive and presumably unreinforced soft story structure which are infamously terrible during earthquakes. It should have never been built with that design in an area prone to occasional earthquake shaking, especially since early indications suggest the structure only experienced MMI 4.0 shaking. Please, don't build any more of these types of structures if they are not properly reinforced in areas which can even occasionally experience potentially damaging earthquake shaking. I beg you. Moving on, other notable damage this time back closer to the epicenter included the collapse of the major Ava Bridge in multiple segments, which had been standing since 1934. But, why did this earthquake strike? Well, while not widely known, Myanmar, Burma sits geologic setting at the boundary of not 2 but 3 tectonic plates. Offshore of the west of the country the Indian plate is subducting underneath the Burma microplate. However, the motion of the Indian plate is not straight east but angled north-northeast, so as a result most of the motion is northwards rather than eastwards. As a result, this motion places significant strain on the boundary of the Burma microplate and the Eurasian plate, causing stress to be released on occasion via the movement of the Zagawang Fault. Today's earthquake was caused by a 250-kilometer or 155-mile-long segment of the Zagawang Fault rupturing and moving by as much as 5 meters or 16.4 feet. The motion was almost entirely horizontal with very little if any vertical motion component to it, hence the nature of this major right lateral strike-slip fault earthquake. However, another type of earthquake damage has also likely occurred, and I do not simply mean landslides which are modeled as likely being widespread. Since much of the worst affected liquefaction area is a massive alluvial plain with larger cities being in close proximity to riverbeds, very widespread liquefaction likely happened. Since these soils contain abundant groundwater that is largely held together by friction, an earthquake can cause this water to shift and then come out of the mixture, making the soil subside unevenly in sections. This can cause the ground to collapse underneath a building in a process known as liquefaction. Aftershocks in the upcoming days to weeks, you can expect more lesser magnitude aftershocks to occur, although the rate of such aftershocks tends to decrease with a rate of 1 over x with x representing time. The largest aftershock tends to be about 1.2 magnitudes lower than the main shock quake, and what do you know? A magnitude 6.4 aftershock struck 12 minutes after the main quake. Please, stay safe.